Welcome to the unit circle, a fundamental tool in mathematics. We begin with a circle of radius 1, centered on the coordinate axes. This yellow line represents our radius, ending at a specific point with coordinates x and y. Now, watch as we rotate the radius and drop a dashed line to the x-axis. The horizontal length shows that the cosine of theta equals x, while the vertical height shows that the sine of theta equals y. As the point moves through a complete rotation, notice how the rectangle tracking our coordinates changes shape, while the radius remains constant. This geometry is summarized by the equation x squared plus y squared equals 1, which describes the right-angled triangle formed by any point on the circle. Let us explore the relationship between circular motion and trigonometry. We begin with a circle and a point moving along its edge. As the point rotates counterclockwise, its position changes in a predictable way. By focusing on vertical motion, we can map the height of the point onto a set of axes to create a sine wave. Notice how the height y oscillates up and down as the point completes a full rotation. This complete cycle across the graph is called the period, representing a full trip of 2 pi around the circle. If we instead map the horizontal position of the point, we generate a cosine wave. Notice that while it has the same shape as sine, it starts at its maximum value. We can define these waves using a general formula. By changing the amplitude, we stretch the wave vertically, making it taller. By adjusting the frequency, we change the period, compressing the wave horizontally. These repeating waves are everywhere in nature, modeling everything from ocean tides to sound and light. Today, we will explore the world of tangent and reciprocal functions. We begin with a standard coordinate system and a circle. Within this circle, any point is defined by a radius, where the horizontal part is cosine and the vertical part is sine. If we place a vertical wall at the edge and extend our radius, we create a ray that intersects this boundary. Think of this ray as a spotlight. As the angle grows, the intersection point on the wall moves rapidly upward. When the ray becomes vertical, it never hits the wall, showing why the function is undefined at 90 degrees. Mathematically, the tangent is the ratio of sine to cosine, representing the slope of the radius as it rotates. Beyond tangent, we have reciprocal functions, like secant, which is defined as 1 over cosine. We can also define cosecant and cotangent as the reciprocals of sine and tangent, respectively. These 4 functions expand our toolkit, connecting the simple geometry of the circle to the broader relationships found in trigonometry.